Okay guys, how are you? In the previous video we solved this specimen paper for 23 O-level physics. We solved till question number 22. Now let's start from question number 23. The diagram shows an uncharged ball covered with a metallic paint. The ball is suspended from an insulating thread. It is placed near a positively charged rod. Okay, so the ball is brought near a positively charged rod. So we know that due to electrostatic induction, an opposite charge will develop on the near end of the ball and like charge will develop on the far end. So this end will become negatively charged and this will become positively charged. So option D will be the correct one. Next question. A charge of 45 coulomb flows through an electric appliance in 3 minutes. What is the average current in the appliance? We know the basic formula for current is I is equal to Q over T, means charge over time. Charge is 45 coulomb and time is 3 minutes. 3 minutes means 3 times 60 seconds. 180 seconds, we need to convert it to seconds, right? So after calculation we see 0.25 ampere is the right option. Okay, next question. A wire of length 0.5 meter and cross-sectional area this 1.0 times 10 power minus 6 square meter has a resistance of 0.75 ohm. Yes. Another wire of the same material has a length of 2 meter and cross-sectional area 0.5 times 10 power minus 6 square meter. What is the resistance of the longer wire? So basically there are two methods to solve this question. First is that let's find out the resistivity. We know that the formula to find out resistivity is that resistivity is equal to resistance multiplied by cross-sectional area divided by length. Okay, so resistance is 0.75, cross-sectional area is 1.0 times 10 power minus 6 square meter over length. Its length is 0.5 meter. Okay, if we put all of these values in a calculator, we get the value as, let me calculate it, 0.75 times 10 power minus 6. So it is 1.5 times 10 power minus 5 ohm meter. This is resistivity. Now the length is 2 meter and cross-sectional area is this. Put these values here and get R. So in the same formula of resistivity, we use resistivity here in place of resistance. 10 power minus 5 is equal to R. Cross-sectional area is now 0.5 times 10 power minus 6 and length is 2.0 meter. Okay. Now after calculating it, we will get the value of resistance, which is option D. Okay. Okay, as I told you, another method of solving this question is that using the concept of resistance. We know that resistance is directly proportional to the length. Resistance is directly proportional to length and it is inversely proportional to cross-sectional area. So look, the length of wire was 0.5 meter. It has become 2 meter. It means length has increased 4 times. So resistance will increase 4 times because of length. Okay? And cross-sectional area was 1 multiplied by 10 power minus 6 earlier and now it is 0.5. So cross-sectional area has become half. We should know that resistance is inversely proportional to cross-sectional area. So if cross-sectional area is becoming half, resistance should become double because of this cross-sectional area. So 2 times of this. So total, the resistance should increase 8 times. Okay? So if you multiply 0.75 by 8, you will still get this 6 ohm answer. Okay? So you can use both techniques. I prefer this one by using the concept of resistance, more smart approach, because the using formula for resistivity, especially for an O-level students, seems problematic mostly. So the using the technique of direct and inverse proportionality will help a lot. Okay, question 26. Which electrical symbol represents a fuse? So we should know that fuse is something that controls the current, and there is a wire inside, so option B is the correct one. Next question. 3 identical resistors are joined in series to a battery. Voltmeter Q reads 8 volt. So here we have 8 volt. What is the reading on voltmeter P? What is the EMF of the battery? Okay. So we have to find out the reading here, what it should be, and the EMF of the battery. So as it is stated that the resistors are identical and they are in series. So if these 2 resistors are identical and they are giving 8 volt total, so it means each resistor is consuming 4 volts. So P should read 4 volt. And EMF will definitely, since it is a series combination, so EMF is sum of all individual resistors using voltages. So the sum of these is 12, so option B is the correct one. Next question. The EMF of the battery in a radio is 3 volt. The resistance of the circuit in the radio is 6 ohm. The radio is switched on. How much energy is transferred from the battery in 30 minutes? So since here V is given, R is given 6.0 ohm, and time is given. 30 minutes means 1800 seconds. So using the formula, you know many formulas of electrical energy. So electrical energy, one formula is this IVT, then another form of this I square RT, then another form V square over RT. So according to the data given to us, this formula seems more applicable. So if you put values here, times 1800, and you will get option number C. Next question. What is the unit for energy used by an electrical appliance? So electrical appliance, we use energy used in kilowatt hour, which is also 1 unit of electricity. Next question. A magnet oscillates vertically above a coil of wire. As the lower end of the magnet oscillates between P and R, a varying EMF is induced across the coil. When this EMF is 0 volt, where could the lower end of the magnet be? So in this question, we see that this magnet is oscillating between 2 extremes. It is oscillating like this, and we know that an oscillating body stops for an instant at its 2 extreme position. So it will, oscillating object stops momentarily at extreme positions. And also, from Faraday's law of electromagnetic induction, we know that induced EMF is directly proportional to rate of change of flux. And flux changes when the magnet is moving. So magnet stops momentarily at positions P and R, right? At position P and R, these are extreme positions, lower extreme and upper extreme. So magnet will stop momentarily. So at this position, there will be no EMF, means EMF will be 0. So option C here will be the correct option, that EMF will be 0 volt at these extreme positions. So now let's move to the next question. Which transformer arrangement produces an output EMF that is larger than input potential difference? So output EMF is larger. So we have read two types of transformers, step up transformer and step down transformer. Since they are saying output is larger, it means they are asking for a step up transformer. And we know step up transformer has more turns in primary coil, more turns in secondary coil than primary coil, right? So option A and B both having more number of turns in secondary coil, but there is a problem with option A, that it is showing DC input. We know that transformer works on AC input supply, so option B should be the correct one. Next question. Why is a relay used in a switching circuit? So basically they are asking for the main purpose of relay. So relay is a small switch through which a small amount of current flows, and it controls a large current, controls a large circuit. The example of relay is the switch of car or any vehicle. The switch is a small circuit, but it operates or it controls the whole circuit of the vehicle. So option C is the correct one for number 32, to switch on a large current using a small current. Next question. A horizontal beam of electrons passes between the two poles of a magnet in vacuum. In which direction is the beam deflected? So direction of magnetic field is north to south, like this. Electrons are moving in this direction. So we know that the flow of electrons is opposite to that of current. So it means flow of current will be taken in this direction, current direction. Now use Fleming's left hand rule. Fleming's left hand rule, this one of 3 fingers. Okay, so if here I should make an orientation like this, that downward is the field, this is the direction of current. Okay, basically not this is the direction of current, this one is the direction of current, right? So applying Fleming left hand rule, we see that electron will move out of the page. This is basically out of page direction by using Fleming's left hand rule. So option B will be the correct one. Next question. How many neutrons are in one neutral atom of krypton isotope 3684? So 84 is the nucleon number of it. 36 is the proton number, so definitely 84 minus 36 will be the correct option, which is option B. Next question. Carbon 614 represents a nuclide of the element carbon, and this is a nitrogen element, represents nuclide of the element nitrogen. How is a neutral atom of nitrogen, this 714, differs to a neutral atom of C614? What's the difference? We see that nucleon number is same in both. So, but proton number 1 is having 7 and 1 is having 6. So, number of electrons and proton will be the same as they are neutral atoms. So, we can say that they have this nitrogen atom, since its proton number is 1 greater, so it has 1 proton greater. Obvious question. Next, radioactive isotopes emit 3 types of radiations. Which list gives types of radiation in order of their ionizing effect from greatest to the least? So we know that alpha has most ionizing ability, beta lesser as compared to alpha, and gamma has 0 ionizing ability. So definitely in this sequence, greatest to the least, so alpha should come first, then beta, then gamma. Option A is the correct one. Next question, which statement about the half-life of a radioactive isotope is the correct? Basically, here they are asking the definition of half-life. Half-life is the time it takes for mass. No, mass, it is not related with the mass. Half-life is half the time it takes for the number of nuclei, no, not number of nuclei, to decrease to 0. No, it's basically number of nuclei to decrease to half. So option D is the correct one. Half-life is the time taken for the number of nuclei of the isotope to half. Option C is also not correct. They are asking about nucleon number. No. 38. Light from the sun travels to Earth at a speed of this. So this is related with space physics. Time for the complete journey is 500 seconds. Means the time taken for light to travel from sun to Earth. What is the average orbital speed of Earth in its orbit around the Earth? So they are asking orbital speed of the Earth. So basically first we will find out distance. This question needs a bit more calculation. Look, let's suppose this is the orbit of Earth and here we have sun in between. Here is Earth. The distance that light takes to travel from sun to Earth will be actually the radius of this circle. That distance will be found by multiplying this speed with this time, because this is the speed of light and this is the time that light takes. Light beam travels like this. Okay, so first let's find out this distance. Means 3.0 times 10 power 8 multiplied by 500. Okay, so we will have the distance. It will definitely come 1.5 times 10 power 8 into 10, 11 times 10 power 11 meter. Okay, this is the radius now. So since we have to find out orbital speed, so you know speed is equal to distance over time again. But here in now distance will be taken of one orbit, one complete orbit. That distance will be 2 pi r. And time is 1 year. This time is basically 1 year. Means 365 days. Multiply by 24. Convert it to second. Multiply by 60. Multiply by 60. 24 days have 365 days have 24 hours, then 1 hour has 60 minutes, then 1 minute has 60 seconds. That's why I have multiplied this. And here in place of r you will put the value 1.5 times 10 power 11. So after doing all of this calculation, you will get the value of orbital speed as option number C. Next question. In the sun, energy is transferred from an energy store. Which energy is being released and what is the name of reaction that releases this energy inside sun? So we know fusion reaction takes place inside the sun, and That is a nuclear energy which is obtained as a result of this process. So option D is the correct one. Now last question. The light emitted from a galaxy is redshifted when detected on Earth. How does the frequency of the light when detected on Earth compare with its frequency when emitted, and in what direction galaxy is moving? So there are two types of shift, red shift and blue shift. Red shift means galaxy is moving away, right? Since it is moving away, so frequency is decreasing and wavelength is increasing basically. So option A will be the correct one, that less than frequency of emission and away from Earth. Okay. So if you have any queries, you can ask me on my number, and please subscribe to my channel.